Alright, let's try a mock assessment. This guy has success rate 35, this guy has 42, this guy has 28. I want to be simple, so I want to do the one with the highest success rate. We'll have 1.5 hours for around 3 questions or up to 3 questions. So how many questions do we get? We only get 2 questions. How do I change it to black? First of all, I want to change. Oh, I can't exit. Alright, let's live with this for now. Okay. So given an array of distinct integers, find all pairs of elements with the minimum absolute difference of any two elements. Return a list of pairs in ascending order. Each pair A B follows A comma B are from array whatever. Let's understand again. So we are given an array of distinct integers like this. Find all pairs of elements with the minimum absolute difference between any two elements. Okay, this guy has minimum difference 1, this guy has minimum difference 1, this guy has minimum difference 1. Pair AB should follow like A comma B are from array A is less than B and B minus A equals to the minimum absolute difference of any two elements in the array. The minimum absolute difference is 1. List all pairs with difference equal to 1 in the ascending order. Fair enough. So you can find out the minimum difference. So basically, if let's say I sort this array, okay, so I sort it. After that, I know 1 2 2 3 3 4 is the answer. That was easy. This is already sorted. So 1 3 difference is 2, 3 6 the difference is 3. So the minimum difference is only this, which is fair. Again, this is again sort of sorted. I think I get a general sense. Let's try that out. So I do arrays dot sort. So you sort it, and then you find the min difference equals to okay. So if you do min difference equals to math dot min, you get to array of I minus array of I minus 1. So this becomes the min difference. So now you get the min difference. Now you want to see how many pairs are there with the same min difference, and for each and every pair you add them to the list. So a list of integer so you do an array list. Now you go for each again same thing, I equals to 1 is less than array dot length I plus plus if array of I minus array of I minus 1 if it's equal to min diff, then you want to do result dot add so that's that. Now I want to do, okay, let's run code to fix the compilation errors. The output is wrong. Okay, there is a mistake here. So this works. Run for all test cases. So you see 1 2 3 4 1 3, the minus 14 10 19 23 23 27. Okay, let's submit. Cool. Let's go to the second question. An underground railway station. Okay, this is a quite a big detailed question. Some sort of a data structure or class definition. Okay, an underground railway station is keeping track of customer travel times between different stations. Okay, so you are keeping track of customer travel times between different stations. They're using this data to calculate the average time it takes to travel from one station to another. Implement the underground system class. An underground railway station is keeping track of customer travel times between different stations. They are using this here to calculate the average. Okay, I just lost track a little bit. Let's see it again. There is an underground railway station. It's keeping track of customer travel times between different stations. They are using this data to calculate the average time it takes to travel from one station to another. Okay. Implement the underground system class this. We want to implement check-in ID station name T. A customer with a card ID equals to ID checks in with the station number station at time T. Customer can only be checked in into one place at a time. Now define checkout. A customer with a card ID equals to ID checks out from the station name this at time T. Fair enough. So check in, check out, and get average time. Average time it takes to travel from start station to end station. The average time is computed from all previous traveling times that happened directly, meaning a check-in at start station followed by a check-out from end station. The time it takes to travel from start station to end station may be different from the time it takes to travel from end station to start station. Interesting. There will be at least one customer that has traveled from start station to end station before average time is called. Okay. You may assume all costs of check-in and check-out methods are consistent. If a customer checks in at time t1 and checks out at time t2, then t1 is less than t2. All events happen in chronological order. Okay, let's look at this example. It's quite a big example. Let's also see this. Okay, so ID is around 1 million or what? Yeah, around 1 million. Station names, station, and not that much. All strings consist. Okay, so I mean there is a small string, not that big string. Strings consist of uppercase and lowercase English letters and digits. There will be at most these many calls in total to check in, check out, and average time. Answers within 10 to the power minus 5 of actual value will be accepted. Interesting. Let's look at this. So this is how the input comes, and you don't have to worry about the input. It's already handled. You just have to implement this class. So underground system equals to new underground system. You check in 45 Layton 3, check in 32 Paradise 8, this. So between Paradise and Cambridge, I think the only thing that you need to keep track of, so who checked in at Paradise and who checked 32 checked in at Paradise, 32 checked out at Cambridge. So it took 14 minutes or whatever. So that's the time. Now you need to keep a running average. So 1, 2, 3. So first we need to figure out how to keep a running average. Okay, so for example, let's take 2, 4 and 6. Right, so if you just do 2 and 4, what's the average? So 2 and 4, the average is, so basically 2 plus 4 by 2 plus 6 by 2. Does that work? This will be 4 plus 2, 6, 6 by 2 is 3, 3 plus 6 is 9, 9 by 2 is 4 and a half. And if you just sum all of them, 2 plus 4 plus 6 by 3, 4 plus 2, 6 plus 6, 12, 12 by 3 is 4. So completely different, right? So you can't, so when you do the average, you have to keep I mean, you can give the sum and the count, but that's a bit harder. Sum of times can be a bit harder. Time itself is too big, right? And if you keep summing them, the number of people are also quite high, so you shouldn't try to do that. So I would say keep track of this, keep track of trip. So trip is start station and end station. For every trip, keep track of these two things: average and trips. So if there's a new trip, then what do? So you do is this: you do average time trips. It's quite big. Well, that's the sum, right? So you could keep track of the sum itself then. See, the total calls itself is this many to check in, check out. So you don't have to worry about 10 to the power 4 plus 10 to the power 6. I mean, it just remains 10 to the power 6. So you just keep the sum then. Okay, then keep track of the sum then. Fine. So you keep track of the sum. Now what kind of a data structure do we use to get the average? So basically, to get the average, I need a start station and station. So for every start station there has to be an end station. So for every trip, for every check-in you need to know open trips, right? So for every open trip, so I want for every start station and station that I get, I can just do start sorry, I can just do start station underscore and station as a key, and the value would be, so you can define, a class data of a route, right? What for every route what you want to save is, begin with this, and you'll have a default constructor which is completely fine. Now you're gonna have, in the underground system you wanna keep also define a, so for every user, So when you're checking in, you have to do this. uh, ID, session and time, right? So for every user, you need to keep station and time. So now when you're doing check-in, you want to do this. You have to know that station, it's because it's in that order. You want to maintain a map of user ID and check-in. All right. I need to see how to remove a key from, so let's quickly see Java map remove key. Okay, let's see this. Okay, let's do I just want to understand what exactly remove does. Does it return a value? So removes the mapping for a specified key when the map is present. What does it return? Previous value associated with the key or null if there are no mapping to the key. Fair. So now this is what check-in will do. So check-in will do this. Map.put ID new check-in station name and T. That's all it will do. What will checkout do? Well, if you're checkout, that means you would have checked in, right? So So remove this guy, and now you get so let's create this key. So we'll have a map with a string and route data. And you can always, if you want, yeah, that's fine. So you have the sum and times and trips. So if sum equals to so the time taken is equals to so no, wait, hold on. So you do instead of map you call it check in events, and you go now you do routes dot put, this is your key, and so you get routes dot put key, you get new route data. And what is the data? So you want to send the sum time, which is time taken, which is t minus start dot t, I guess. Yeah, this is the time and trip is 1, right? Else data equals to now you want to get average. Well, you do this. And then you do sometimes let keep it in double. Not double, rather long. Data dot okay, let's run code. Okay, there is a problem. It's not. There's another problem. This, I mean, it's not sometimes, it's sometimes. Okay, let's see the answer that we get. 14 11 null 11 null 12. 14 11 null 11 null 12 seems to work. What's the other one? Null 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 5 null null 5.5 null null. Okay, seems to work as well. Taking a lot of time though. Oh, it worked. Let's finish. Let's open these problems separately. Okay, this is something we had done in the past. It seems like okay, finally it looks okay. The approach. This doesn't look that bad, and did it now. Okay, still not that bad. And that's the score. Alright,